Welcome to the recording for Chapter 9, Monitoring Methane Emissions for the Methane Abatement Handbook. We're joined with a special guest, Deanna Haynes, who's a Senior Director at Honeywell and was also one of the contributing authors for the Methane Abatement Handbook. The handbook can be accessed at this website. While Chapter 9 will be the focus of this presentation, we won't be able to get into all the details in that chapter, so please do take a look at the handbook. A huge thanks to our funder and supporter, the State Department Bureau of Energy Resources, for the handbook and all the supplementary work. And with that, Deanna, I'll turn it over to you to cover Chapter 9.
Thanks, Bria. Appreciate it. So the key takeaways around monitoring are that there are a lot of different monitoring technologies, and they're available on the market, and they each have their own different limitations and optimal use cases. So as a regulator, you're going to want to take the best of the measurement technologies for your particular applications, and keep in mind that there could be a portfolio of measurement technologies that you will use to support your monitoring. But monitoring is a real key area. If you can't measure and monitor the emissions, you really can't manage it. So the policies are not going to be effective if you are not able to effectively monitor and measure these emissions. Next slide. So in terms of the available technologies, right now, most of the type of technologies that are being used are what are called optical gas imaging cameras, where somebody goes out and physically reviews a site through an optical lens, a camera, and goes to the different areas where there could be sources of emissions. And it's a pretty labor-intensive process, and it requires a lot of training to make sure that they get the right distance away from the potential source, that they are paying attention and staying, having what is called a dwell time on that particular emitting the source, so that they could get, and that they have a contrast, a thermal contrast, so that they could see if something's happening. So there's a lot of training that has to go involved, and but it's a good method to be able to see things from afar if they can't have direct access. The other method that is typically used is what's called an EPA Method 21 sniffer survey, which is an instrument that is literally, you go right next to the component, it sucks up the leak that may be emitting at that component level, and it gets a concentration of that leak in air around that particular component. These require extensive labor sources, and they are, of course, intermittent, but those are the typical ones that are done today. There's a lot of new emerging technologies now that can help you get data over large areas through aerial surveys, satellite surveys, and also within a facility. There are some new sensors that are out that are called continuous sensing devices that can measure methane in air, and can be used in conjunction with like a wind meter, and to help you come up with plume modeling to get quantification. And then, of course, you could use the data from the process itself. Digital twin type data, where you could understand, how the process works, how it is designed, and what emissions would be coming from just using process data. Ultimately, it is helpful that you have what I call a tiered monitoring approach, where you may have some data that's coming from aerial or satellite, and combined with some data that's coming from a process, from the process itself, and calculations from the process. Or ultimately, if you're able to get fixed monitoring, that could be pulled in. The idea is that you're going to want to mix and match depending on the use case and what you're trying to achieve, and different sources are going to be needed to help you manage this issue. Next slide. Here's an example of kind of the monitoring that I was talking about. This tiered monitoring approach, where you could have fixed sources on a tower looking over a large area. Within a facility, you could have a fixed camera looking in a large area, or some type of fixed sensing device. There's lots of mobile systems now that can go to the perimeters of facilities and get a sense of what may be coming downwind of those facilities. So there's a lot of opportunities to get different types of measurement, but each one of them will have their own uncertainties, will have their own ability to drill down and pinpoint, let's say, a particular leak, and will have their own use cases. The idea is, though, that you'll have different ways of coming up with a sense of what the emissions are, and help you properly manage and monitor those to get those reductions. The key thing is early detection, so that the regulated community can respond quickly to reduce and abate those emissions. Next slide. Here's an actual examples of the different technologies. Up in the upper left are the satellites and some of the imaging that can happen. And down below is a mobile system. This particular example shows a car being driven through a neighborhood, and you could see through color changes enhancements in methane in the air, where the methane hotspots may be. On the right, the camera that I was talking about, where you can look at the top of a tank from afar, and optical gas imaging, and then through infrared thermal sources, you could see the emissions. Fixed camera, Honeywell, and this is a particular Honeywell technology where we could actually differentiate methane from other gases. So this is an example of where you could actually see the leak, and see methane in particular through what's called a hyperspectral camera, where it just sees methane. And then below is an example of a fixed sensor. This is another Honeywell technology where you could put the fixed sensor literally near a thief hatch or near the potential source pneumatic rack, and start seeing the emissions that may be happening. And then you'll know when things are controlled if you are able to fix it. But this is something that could be an early continuous detection and help you catch intermittent releases between, let's say, leak detection and repair surveys. Next slide. So in terms of supporting the regulatory framework, there are ways to incentivize carrots and sticks, so to speak, to help folks reduce their methane. One is just to assign a fee. If they trigger a threshold, they go over a threshold, you assign a cost to that. And that way you send a signal that if they exceed this threshold, then they're going to be paying this much money, and that can help them decide how much monitoring and mitigation they could do to basically avoid triggering those thresholds. So that is a direct kind of market-based approach where you assign a cost to that release, that methane emission. And that helps drive incentives for the customer or the regulated community to understand what is worth it. What is it? Is it easier for them to put in the monitoring and mitigate those emissions than pay that cost? So that's a really good direct way to help drive reductions. And then, of course, there are some technologies that you should consider that helps, get you the data to help you address a certain requirement. So the key thing here is that you need to understand what is your main priorities in terms of emission reductions, what will be easily integrated into the regulated communities operations that can make them quickly identify leaks and address them early in the process. So that's the key thing, is to help them get some type of monitoring that can help them detect things quickly, so that they can address and mitigate them as soon as possible to accelerate those reductions. The most important thing is that once you understand and help the regulated community monitor their emissions, you'll need to create transparency around those emissions, obviously, and get those reported and verified through some type of independent verification mechanism. So the key policy framework must involve some type of monitoring, some type of reporting, and a verification aspect to it in order for it to be effective. And each of these technologies that could be employed will have different cost and limitations, as we talked about, in optimal use cases. And that cost and cost effectiveness does have to be kind of considered. You don't want to regulate somebody to put in very expensive monitoring when it's much easier to do it in a cheaper way to find the leak and reduce it. So you really have to keep in mind what works well for the operation, and if there are opportunities to help the operation become more efficient and more optimal, at the same time find that it helps them find those leaks and those releases for early abatement and response. All right. There's lots of support from different organizations and governments. The United Nations has a methane alert and response system, but I particularly have worked with the Carbon Mapper folks, and they have, and both the Environmental Defense Fund, and they have some really good resources. The Environmental Defense Fund just recently launched a satellite that will help get good data on high emitting sources. Carbon Mapper employs aerial surveys mainly, but they also are going to be launching a satellite, and they have a lot of good data and a lot of coverage over large areas of the globe around emissions, and they have it online, publicly available, so that you could refer to those too. So this is, again, a list of those different opportunities to get data, to get a sense of where you may be at in terms of your country's sources at a large scale. And typically these satellite and these aerial surveys are over large areas, and they typically will catch the largest emitting sources, which according to the science, there's typically what's called a fat tail distribution, where just a small amount of sources can contribute significantly to the overall inventory. So if you're able to get after those few large, big sources, that's a really good, effective way to get the low-hanging fruit from your emissions inventory, is to go after quickly those large sources, see if you could reduce those large sources quickly. Next slide. Thank you.
Great. Well, thank you so much, Deanna. And again, if you have further questions on Chapter 9, please do take a look at the handbook itself. Again, a big thanks to our funder, the State Department Bureau of Energy Resources, for their support for this book. Thank you.